In this lesson, we're tying together all the ideas related to proportional linear relationships by representing them in tables, graphs, equations, and with verbal descriptions. Let's start with tables. Stephen works at the local sandwich shop in his neighborhood. He earned $118.50 for 8 hours of work. Looking at our table here, I see that we have a y variable and an x variable. X is the hours and y is the dollars. Actually, let me color code that. There we go. That's better because now I can say I have 8 hours. I can make that green. And then $118, that's my y. So I have my y and I have my x. And what I want to do is use that to find my constant of proportionality. Remember, k is equal to y over x. So what I need to do here is $118.50 divided by 8. I would suggest typing that into Desmos. So this problem is going to tell you that that comes out to $14.81. That should be what your calculator says. And honestly, it has some more decimals after that. I think it's actually $14.8125, like that. Yeah, $14 and 8,125 10,000ths. But nobody actually gets paid like that, right? So we have to consider how we're going to round. And in this case, we round to $14.81. Now we can complete our table. So $14.81 times 0 is just 0. If I work 0 hours, I make $0. And to complete the rest of my table, I'm going to need to multiply each of these values by $14.81. There's actually some pretty neat ways to do this in Desmos. Right now, I'm just going to actually multiply all of these numbers. 2 times $14.81, 4 times $14.81, and 6 times $14.81. And now my table is complete. Let's just talk about a key feature of tables of proportional relationships. You will always find the point 0, 0 on your table. That is what tells us that it is proportional. The other thing that you should notice when looking at proportional tables of proportional relationships is y divided by x is always constant. So 8886 divided by 6 is 1481. 5924 divided by 4 is 1481, and so on. Now let's look at a graph. On a map scale, 2 inches represents 10 miles. Graph the relationship between x, the number of inches on the map, and y, the actual distance in miles. All right, let me get out my highlighter. I believe that last time I used green for x. So in this case, green is my inches. There we go. And I used yellow for y, so I'm going to keep that up. So y is my miles, and there's my 10 miles. All right. I know that k is going to equal y over x. So there we go. Okay, so I'm going to have 10 over 2. And that equals 5. 10 divided by 2 is equal to 5. So that's going to be the slope of my graph in this case. It's called my constant of proportionality or my unit rate. And it's also the slope of my graph. So if I want, I can use that slope to create a table with points, and that's a great strategy. Let me just show you a quick shortcut though. I actually could make the graph with just the information I have right now, because I know that 0 inches is going to represent 0 miles. So I can graph the point 0, 0. Another point that I can graph is the point 2, 10, which is right there, because I was told that 2 inches represents 10 miles. So that information is sufficient to be able to make a graph. There we go. But I also want you to know that you can use a table to create a very precise graph. So I would just create a table like that. I would start with 0. 0 times 5 is 0. Then let's try 1. 1 times 5 is 5. 2. 2 times 5 is 10. 3. 3 times 5 is 15. And 4. 4 times 5 is 20. So my rule that got me from x to y was times 5. And you can see these other points fit on my graph too. There's 1, 5. I already had 2, 10. Here's 3, 15. And here is 4, 20. And now I've labeled all my points so you can see how they correspond to the table. Also, for any value on my graph, if I divide the y coordinate by the x coordinate, I will get 5, which is the slope of my line. In fact, it would be great to write the equation of this line right above it so that I know the equation corresponds to the graph. All right, let's look at equations now. We already kind of have been looking at equations. But let's look at one more example here. So Layla earned $80 for 6 hours of work. She earned the same amount each hour. Write a function that represents the total amount of money earned, D, for working H hours. So what we are looking for here is dollars per hour. We have $80 and we have 6 hours. So we need to know what 80 divided by 6 is. Oh my, that comes out to $13.3333333333 forever threes. I could write that like this, but I wouldn't do that when I'm using money. With money, we're going to need to round because we can't earn just part of a dollar. So in this case, we're going to round to $13.33 per hour. So that's my K, right? So I used this equation, K equals Y over X, to find what K is. It's equal to $13.33. And that is my slope. So I can write Y equals $13.33 times X. In other words, the amount of money I earn is equal to $13.33 multiplied by the number of hours that I work, or in this case, the number of hours that Layla works. Excellent. Okay, let's make some connections over here. On this one, we're going to have a table and a graph. On a map, 2 inches represent 60 miles. Write a function and create a table and a graph that represent the relationship between x, the number of inches on the map, and y, the distance in miles. All right, so I have been using green for my x. Whoops, that's yellow. Let me get green. There we go. I've been using green for my x values. So I'm going to highlight all of those. In this case, it's inches. I've been using yellow for my y's, so let me highlight that. There we go. In this case, it is miles. All right. So one point that I can already write on my table is 0 and 0, right? Let me make that black so it's easier to read. And we can also add the value, the point, to 60 because 2 inches represent 60 miles. That was given to us. So this is actually sufficient information to create the graph. We can graph 0, 0, and we can graph 260. We can't perfectly graph 260, but we know 60 is a little closer to 50 than it is to 75. So my point should be between 50 and 75, but a little closer to 50. Okay, so I've got those 2 points and I can connect them. There we go. All right. Didn't mean to do that. Maybe I'll add that line later after I'm done zooming out. But we could draw a line between those now. The graph could be complete. But there are some other things that I want to think about here. For one thing, I want to find my unit rate. I want to know the slope of my line here. We know that K is equal to Y over X. So just using some values that I have, I could say K is equal to 60 over 2. That's 30. 60 divided by 2 is 30. So the slope of my line is going to be 30, and I could say that 1 inch represents 30 miles. Maybe I should write that down. 1 inch represents 30 miles. That is also all that I need to know to be able to write an equation. I can now write y equals 30x. The number of miles equals the number of inches multiplied by 30. Let's use that to complete our table. So whatever I have for x, I'm going to multiply it by 30, and that should give me my y. 30 times 0 is 0. 30 times 2 is 60. You know what? Let me do a slightly bigger point. How about 30 times 4? So I'm going to jump around a little, and that's okay. 30 times 4 is 120. How about 30 times 5? 30 times 5 would be 150. And these are also points that I can graph. So 0, 2, let's see, 4, 120. It's going to be closer to 125 than it is to 100. and then 5, 150. Oh, finally a pretty point. We call this a pretty point because it is at the intersection of two values that are on my axes. So 5 is on my x-axis and 150 is on my y-axis. That means that this point right here is pretty. It's very easy to graph. I don't have to estimate to graph that point. All right, now I am going to draw a line through these 4 points. And I'm going to leave it there this time, hopefully. Excellent. And so I could say the slope of this line is 30. Whenever x goes up by 1, y goes up by 30.